Hi, in this video I would like to talk about how a negative number is represented in a binary number system. So in order to do that, let's first take a binary number. Let's say a 25. It's a decimal equivalent, and the binary equivalent of 25 is 11001. But the standard way of number representation is 8-bit representation, so let's do an 8-bit representation. So I'm filling up the rest with zeros. This is the MSB here, MSB, and this one is LSB. So this is a positive number, positive 25. But when we represent the negative 25, there are two ways to do that. One is 2's complement representation, and another one is 2's complement representation, and another one is signed magnitude representation. Let me write it little below. Signed magnitude representation. Signed magnitude representation. So there are two different ways, and the result will be two different numbers, two different binary numbers. So first let's talk about how the 2's complement representation is. To do the negative 25 in 2's complement representation, we just find the 2's complement of the whole 8 bits. So the 2's complement will be, let's start from the right side, and we see that there is a 1 there, as I discussed in the previous video how to find the 2's complement of any binary number. There is a quicker way. So we first start from the right hand side going to the left, and until we get the first one we do not change anything. Here this is the first one in the beginning, the LSB is a 1, so we keep that 1 and then we invert everything, so it becomes like that, 1 1 1. That is the negative 25 in 2's complement representation. So this is the 2's complement representation of negative 25, and we can see this is the MSB here and this is the LSB, just like the positive number. Now the signed magnitude representation of the negative number is a totally different method. So here the MSB is reserved for sign. When the MSB is 0, that is a positive number, and when the MSB is a 1, that is a negative number. So in order to do that, to represent negative 25 in terms of sign magnitude representation, what we have to do is we just write the 7 bits. So this is the number, these two as well, but the MSB, which is the most significant bit, since this is a negative number, this will be 1. So this is negative 25 in terms of sign magnitude representation, and we can see the two numbers are totally different. The 2's complement representation of negative 25 is 1 1 1 0 0 1 1 1, while the sign magnitude representation of negative 25 is 1 0 0 1 1 0 0 1. They are totally different. So we have to remember, whenever we are expressing a negative number, the positive numbers will be same in both kind of representation. So we have to first see which kind of representation is this. If this is a 2's complement representation, then we have to find the negative number in certain way, and if it is a sign magnitude representation, we have to find the negative number in another different way. And this thing is very important to remember, that they are very different. When we talk about the weight of a 2's complement number system, so I will just erase this part. When it comes to the positive value, the weight of the MSB is 0, like that, 2 to the power. So this is the weight of a positive value for a 2's complement representation. So this is 1, this is 2, this is 4, this is 8, then 16, 32, 64 and 128. However, this is the weight of a positive 2's complement representation of a positive number, while the negative number is just like that. Here, if a negative here, so this is minus 128. So if we see this negative 25 and we assign the relevant weight to each of the bits, we will see that this one is a 1, so this is 1. So I will do it here. Probably I will erase this part and I will do the calculation over here. So this is a 1, then this one is again a 1, so this is 2, this one is a 1, so this is a 4, then here this is 1 2 0 1 2 3 4 5, so this is a 5, so this is plus 32, this one is a plus 64, and then finally this one is a negative 128, negative 128. So if we add them up, we will see that it will yield minus 25. So let's do that. So 32 plus 9 is 41, 64 plus 41 is 5 here, and here this is 10, and this is minus 128. So minus 128 plus 105 gives minus 25. So this is how it turns out to be negative 25 as well, as the most significant one's weight is negative weight, or like since this is a 8-bit representation, this is 2 to the power 7, negative 2 to the power 7. If it were a 4-bit representation, it would be negative 2 to the power 3. So I can do another example, maybe a 4-bit example this time. Let's just say positive 3. The number is in terms of 4, it's a 4-bit, it will be a 4-bit representation, so 0 0 1 1, this is positive 3. Negative 3 in terms of first let's do 2's complement representation. Negative 3 will be just the 2's complement of that one, so this is a 1, this is 0, this is 1 1, and let's check the weight again. So this one is 2 to the power 0, 2 to the power 1, 2 to the power 2 minus 2 to the power 3. That gives us 1 here plus 4 here, and then plus here it is minus 7. So minus 7 plus minus 8. Yep, minus 8 plus 5 gives minus 3. So this is how we get minus 3. If it were a sign magnitude representation, it would be sign magnitude representation would be just 1 1 there, 0 here, and this bit is reserved for negative. So this would be the negative 3 in terms of sign magnitude representation. So this is sign magnitude, while that one is 2's complement. So yep, I finish my video here. If there is any comment or any feedback, please leave that. Thank you.